Okay.
Hold on, I got a couple photos to send with this one. Hold on, I got a couple pictures to send here.
Okay. Oops.
Okay, sending you them now. Alright. It may take them a little bit to get there, so.
Okay. It's definitely worth you reviewing each of these little squares in each subchapter. In other words, the one on rhombuses, rectangles, and squares, and the one on trapezoids and kites. Have you had kites?
Yes, I do believe so. I think so. Maybe.
Know what the area of the kite is?
I don't think I learned that.
Actually, if you
Yeah,
turn the page and look under 6.7, gives you all your area formulas of the triangles and different quadrilaterals, the trapezoids, and the kite.
I don't even have a 6.7.
Really? Wow.
Yeah.
Huh.
Must have cut kites from the program.
Yeah, they must have. Although, you must have somewhere on there where you have the areas of each of these. So they must give you a formula for the area of a trapezoid, which is 1/2 the height times the base 1 plus base 2. Areas for a kite is 1/2 the diagonals multiplied together. There's a number of things that I'm assuming you have to memorize. When you take your tests, they don't give you those formulas, am I correct?
Well, what are you talking about?
Well, if they said give me the area of a parallelogram, they're going to depend on you having that memorized, right?
I don't think we did any areas really, truly with this stuff. I think we just worked on the insides.
Oh, really? Okay. Well, there's a perfect example of why I need you to bring the problems, because I wouldn't know where to begin, not having been there.
All right.
You will get that at some point, for sure. Oh, here it is. Start with the first one. The one that says image.
Hold on, let me flip back the page.
Let's see, that's 6.
Sure.
Okay. So in 6.4, we're talking about rhombuses, rectangles, and squares. We know what a rectangle and a square is. A rhombus merely has 4 equal sides, but it doesn't have to have 90-degree angles. In other words, I could make a rhombus like this. That side's equal to that side.
Hold on, wait. Are you showing the notepad right now?
Yeah, you can't see it?
Nope.
How about now? I just moved it higher.
Nope. Hold on, wait a second. Maybe if I... No, I'm still not seeing anything. It just shows you erasure on the notepad.
What are you seeing? Are you seeing my desktop, or are you seeing the image that I've opened that says rhombus's
image? Yeah.
But you're not seeing my notepad journal.
Not the writing. I just see the bottom part of it.
What happens if I fill my screen with it? Can you see any of the writing now?
Nope. I think it froze or something.
Yeah, it sounds like your image froze. Let me see if I can figure out how to unfreeze it.
Oh. The notepad's moving. Hold on. My computer may be catching up. There we go. Now I see it.
Okay. So, I was trying to show how I can draw a rhombus that has 4 equal sides, and yet these are not right angles. So this is not a square. A square has not only 4 equal sides, but 4 90-degree angles also. All right. So let's look at their questions for us here. 21. Here, let me move my notepad so it's not covering this up. In fact, I don't really think we're going to need my notepad here. What is x in 21?
I don't know.
ABCD is a square.
Oh, then 8.
Okay.
X equals 8.
What is y?
8.
Well, y minus 5 is equal to 8. So I would have y minus 5 equal 8. Can you see that?
No. Oh, there it is. It's just lagging a little bit.
It just lags a little bit. Okay. So if y minus 5 equals 8, then what's y equal to?
So if y minus 5, add 5 to both sides, that would be... Wait, no, y would just be 8, wouldn't it?
No,
or
you
do
were
you need to solve for it? No,
you need to solve for
okay.
it, yeah. And look at it. In other words, this side needs to be 8, so y would have to be 13, such that 13 minus 5 was equal to 8.
But then it wouldn't be a square anymore, would it?
It would as long as y is 13. In other words, this side has to be 8. So y minus 5 has to equal 8. But if I'm solving for y, I have to then solve this equation. And it gives me a y of 13, which makes sense because if y is 13, then 13 minus 5 is 8, and that side is what it needs to be.
Ah.
All right. Let's look at 22, which is a rectangle. And they want us to solve for x and y. So the part that's labeled x minus 1, what is that equal to?
Wait, 5?
Yeah. Because these are diagonals, they bisect one another. So if x minus 1 equals 5, what does x equal?
6.
And y plus 4 equals what?
Y plus 4?
Uh-huh. This part here.
5, because if it's all bisecting each other.
Well, and diagonals are equal. In other words, JG is equal to FH also.
Ah. So, then it's
y?
just y plus 4 minus 4, 5. Y equals 1.
Okay. And let's look at 23, which is a rhombus with, it's a rhombus that's not a square. What's y equal to?
I want to say 10, but I don't know if that's right.
It is right, because the definition of a rhombus is 4 equal sides.
Oh, therefore not 4 equal angles.
Exactly. Exactly. And what is x equal to?
X is, so 10x plus 4 minus 4. 6. X equals 6.
Good. Okay, true or false? All rhombuses are squares.
True? Wait, rhombuses? False. False.
No.
Way false.
Some of them are actually cool characters. They're not all squares. There was a rhombus right there that's not a square.
Correct.
Okay, 25. All rectangles are parallelograms.
True.
All rhombuses are rectangles.
False.
All squares are parallelograms.
True.
It must be the even ones are false and the odds are true. No, just kidding.
I'll remember that from ACTs.
Yeah, really. All right, let's see. This top part is about trapezoids. What is angle P?
P?
P? This one here?
P would be 75.
Only if that is an isosceles trapezoid.
So it is parallel only on 2 sides. Doesn't that make it isosceles?
No, actually, yeah, you're right. It's parallel. But if I drew 2 parallel lines like this, without the trapezoid there, and then I draw a line like this, what's the relationship between this angle and this angle?
Oh, they're the same.
Do they look the same?
Oh, wait, no. They're supplementary.
There you go. So what is angle P equal to?
111. Hold on, let me do the little simple math here. 180 minus 11. 69.
Okay. So notice that you don't have to memorize the rules for a trapezoid, at least not this one, because this one can be figured out just by your awareness of parallel lines with a transversal, which is one of the more important things you want to get from geometry. If there's one thing you're going to run into a lot of on your ACT test, it's parallel lines with transversals. And even though a trapezoid is a quadrilateral that has all these rules, half of it, the left half of it there, is just 2 parallel lines with a transversal, just like this side over here. So if this is 75, what's this one up here?
That would be, say, 75. 180 minus 75. Wait, that's easy. That's 105.
Okay.
I try to write it to get it in my mind.
Okay. Now, the next, number 29, they make this equal to that, which is important in that it makes their opposite angles equal also. Additionally, they've made this side equal to those two. I'm not sure that matters, but they want to know what angle C is.
Angle C?
Uh-huh.
Wait, wouldn't,
Let me draw it properly.
109? Wouldn't it be 1C, 1C C be 109?
Does it look 109?
Yeah, it looks
And
like...
I don't say that being sarcastic. I say it because that's a test you should always make,
No,
is to see whether the angle that you're saying is obtuse looks obtuse.
Oh wait, I get it now. So if if both sides are even, that's going to mean that 109 is what A is, and then it's going to be the exact same on the other side, so that means that C would be 71.
Right. Based just on the fact that that is equal to that. We don't even need that to be equal to the other two. In other words, even if this side here were not, that would still be an isosceles trapezoid. I think.
Okay.
I think. Let me think about that for a moment. Let's see. If I were to, could I draw this picture any way different by changing these angles? I don't think so, because if I try to draw it like that, there's no way this side is equal to that side. So yeah, those two angles are fixed based just on the fact that these two non-parallel sides are equal. .30, the length of TU. If you didn't know the rule here, what would your guess be?
Have you drawn something?
No. Can you see the image? Question 30?
Oh, for 30? Yeah, I can.
Okay.
I have the book right next to me. I'm still looking at that.
Oh, I see. Okay. Yeah.
Well, I know that you have to find the number between them at some, but I forget how to. Isn't it like...
What would your guess be? The one side's 13,
So,
the other side's 9, and they're asking about the length of the side that's in between, halfway in between both of them.
11? 11?
Yes. Does it look
I
11?
was yawning.
That's okay. Does it look
Yeah.
11? Yes, it does.
Yeah.
In other words, if you came up with 15, then when you look at it, you'd say, well, there's no way that can be 15. So this last question I keep asking is one that you should be asking yourself when you look at these things. Let's see. That's a trapezoid because these two angles are supplementary, which means that's parallel to that. FG is parallel to JH. Based strictly, again, on parallel lines. Remember that a trapezoid has exactly one set of parallel lines. Only.
Mm-hmm.
If it had two, it would be a parallelogram.
Correct.
Can you see 31? Is 31 a rhombus?
A rhombus? Yes. Wait, no. Because not all the sides are the same. I mean, all the sides on the inside, they correlate, whatever. The angles. I thought every single one... Never mind. Wait, it is, because...
Well, it's not that clear whether it is or not when we first look at it. Here, let me move my thing out of the way. Can you see both my notepad and the picture now?
Mm-hmm.
Okay, so let me try to draw this. So that means that line's parallel with that line, just that much information, right?
Mm-hmm.
And this one is 73, and this one is 107. So if I turn this thing rotated at 90 degrees left, we would know that this has to be parallel to that, based strictly on this transversal. However, notice that just because those angles make this a parallelogram, which they do, it doesn't have to be a rhombus. In other words, I don't know whether this side is equal to that side. And in fact, I can
that's right.
I can definitely draw it so it's not equal. And as long as I can draw it so it's not equal, these angles are still the 4 angles that they gave us. But the fact that I was able to stretch it, a rhombus needs 4 equal sides. So just having these 4 angles only tells us it's a parallelogram, not
a rhombus.
Right. It's 32, a trapezoid.
With 32?
Uh-huh.
No.
And why not?
84 and 79 would have to be supplementary, and they are not. A trapezoid always has 2 parallel sides.
Right,
and those
but
sides are
that's
parallel.
the only problem with what you said was that it's not 84 and 79 that need to be supplementary.
Oh, I mean, 98 and 84.
There you go. In other words, if we view this not as a trapezoid but as a parallel line there and a parallel line there, that would have to be supplementary. Now, it's also the only way we know this line is not parallel to that line is the fact that 84 and 79 also do not add to 180. So, in a sense, you were correct. One of these pairs would have to be supplementary, either this one or this one. And if it was, it would be a trapezoid.
Mm-hmm.
But it really could be either one. Even though from the drawing it looks like if anything's parallel, it's that side and that side, and it's not going to be that side and that side. Okay, is that a rectangle?
No, I mean, yes.
Well,
because we already have one right angle, but the bisect angles are all the same, which would mean it is a rectangle.
Yeah, like a lot of laws in math and geometry, we know that if we have a rectangle, the diagonals bisect one another. And the corollary to that is if the diagonals bisect one another, we have a rectangle. You know what I'm saying? It's similar to the following. Have you learned the Pythagorean theorem for right triangle yet?
A squared plus b squared equals c squared. So essentially, say A was 5, B was 10, and so all I had to do is so 5 squared plus 10 squared would equal c squared, and then it just solves. So.
Right. Yeah. But what I mean by that is that this is true, that if it's a right triangle, the Pythagorean theorem says that this has to be true. Well, the reverse of that is also true. If this is true, it has to be a right angle, a right triangle. In other words, if I give you a triangle like this, and it's 3, 4, 5, this must be a right angle. You cannot draw a 3, 4, 5 triangle without having a right angle opposite the 5 part. So that principle is what holds in a lot of these problems. In other words, this problem right here, the theory said that if we have a rectangle, the diagonals are equal and bisect one another. Well, the reverse of that is true. If we have diagonals that are equal and bisecting one another, and we have a right angle, we have a rectangle. All right, let me close this one and open the next one here. That was image 1, wasn't it?
Those image 2 or 3. Yeah, actually, yeah, we don't even need to go over these because we just did. But, if I was to solve it, because we just got that one.
Okay, so I'm presuming this asks about WX. What's WX?
No, it's asking what line WX is, but yeah.
Yeah.
So 11.
How do you figure it out algebraically? How do you figure out the midway point between 11 and 17?
So it would be 12, 13, 14.
Yeah, you add them together and you divide by 2.
Yep.
So 28 divided by 2 gives us 14. All right, so you want me to close this one out and go to the last image? We got about 8 minutes here. So this is a parallelogram.
Mm-hmm.
That's what this symbol here means.
Yep.
So how would I solve for x? First of all, let's do the easy one. What is y?
7.
Okay. What is 2x equal to?
122.
Do they look the same?
Nope.
Yes, they do.
Wait. Oh, you mean yeah. Sorry.
In other words, they're both obtuse. When I ask that question, what you need to mainly do is see whether one is acute and the other is obtuse, which would mean they're clearly not the same. And that's about the only thing you can really look at to judge whether they're the same or not, is because in all of these parallelograms, one set of the angles is acute. In other words, A and C are both less than 90, and the other set is obtuse. So 2x would be equal to 122, x would be half of that, 61. So in number 6, what's x?
70. That'd be 110.
And what would y be?
110. It would equal to 110.
Well, y plus 10.
It equal to y equals 100.
There you go. I can't read 7.
Oh yeah, I didn't want to get 7. I was just getting 5 and 6.
Okay. Let's see if I can find any interesting ones. That's about it. You haven't had kites? They didn't give you kites? Let's just talk about kites for a moment. You'll remember if you've had it or not. A kite is, in my book, it's in the same section as trapezoids. They look exactly like what you would think they look like, a kite. The area of that kite is 1/2 d1 times d2, with this being the small diagonal and this being the bigger diagonal.
Yeah, I never learned this.
No kites, huh? The definition of a kite is that side's equal to that side and this side's equal to that side. And this is about all there is to really know about a kite, other than this big diagonal bisects the little diagonal. The little diagonal obviously does not bisect the big diagonal. But, okay, so no kites. Any last questions?
Nope, not that I can think of.
Okay. All right. Well, we can wrap it up then. Yeah. I guess I will talk to you next time.
All right.
All right. Okay. Bye-bye.
Okay, bye-bye.